So for problem number 10, we're trying to use calculus to find the arc length of the segment defined by these equations here, where x is equal to 3t plus 1, y is equal to 4t, for t between 0 and 1. Now, if we remember the formula for the arc length, so if I have a curve y is equal to f of x, the arc length that goes between some point A to some point B of the curve f of x is given by the formula, the integral from a to b, of the square root of 1 plus f prime squared times dx. So what that means is that we need to take our curve y as a function of x, we need to take the derivative, square it, add 1, put the square root, and so on. So the problem here is that we don't have y is a function of x. In fact, we have the parametric equations where we have x as a function of t and y as a function of t. So what needs to happen here is we need to eliminate the parameter t so we can just have x and y and then use our formula. So what we're going to do here is we're going to take this equation, x is equal to 3t plus 1, and I'm just going to isolate t in terms of x. So if x is equal to 3t plus 1, I'm going to bring the 1 to the other side. So x minus 1 is equal to 3t, and thus t is going to be equal to x minus 1 divided by 3. So once I've isolated the value of t, this is important because now I can plug it in here. So we have that y is equal to 4t, but remember that t is x minus 1 over 3, which therefore means that y is going to be equal to 4 times x minus 1 divided by 3. And now we're going to distribute the 4 and break up this fraction. So y is going to be equal to 4x over 3 minus 4 over 3. And so this here is our function of x, right? Because we've eliminated the parameter. And now we just have to put the restriction of t, because remember t goes from 0 to 1. So let me erase all this stuff so that we have some space to work with. And if t goes from 0 to 1, let's just plug in these values of t to get the restriction of x, because now x is the input. So if I plug in t is equal to 0, what I'm going to get is that x is equal to 3 times 0 plus 1. So x is equal to 1 for the lower boundary. And if I plug in t is equal to 1, I'm going to do x is equal to 3 times 1 plus 1. So x is equal to 4 for the upper boundary. So we've seen that x is between 4 and between 1. So once we have this information here, we have the boundaries, right? Because now it goes from 1 to 4, but we need to find the derivative of f and then square it so we can use the formula. So y prime is going to be equal to, if I take this derivative, that's just going to be 4/3. And then if I take y prime squared, that's going to be 4/3 squared, which is the same thing as 16 over 9. So once we have this value here, we're ready to set up our integral. So this is going to be the integral from 1 to 4 of the square root of 1 plus f prime squared. And as we saw, f prime is 4/3 and f prime squared is 16 over 9. So 1 plus 16 over 9. And then dx, and so once we have this here, that's going to be equal to the integral from 1 to 4. 1 plus 16 over 9, that's going to be, let's see, multiplied by 9, that's 25 over 9 dx. And that's the same thing as going the integral from 1 to 4. We can take the square root of the upper part, so the square root of 25 is just 5. The square root of 9 is just 3, so that's just 5/3 dx. And if we integrate this, what we get is 5/3 x going from 1 to 4. So we have found our integral, and now all that's left here is to, so let me zoom out, all that's left here is to plug in the boundaries. So now we're going to do 5/3 times 4 minus 5/3 times 1. So if we do this, that's going to be, let's see, 20/3 minus 5/3. And if we do this, that's going to be 15 over 3, which is the same thing as 5. So we have arrived here at the answer for our arc length. And now they want us to check our work by finding the distance between the endpoints of the line segment, right? So remember that the line segment, and I guess let me erase this so that we have some space to work with. Okay, so the line segment, we begin where t is equal to 0, right? So let's plug in t is equal to 0 in the x equation. So x is equal to 3 times 0, as we've done before, plus 1, which is just 1. And if we plug in t is equal to 0 for the y equation, we have y is equal to 4 times 0, which is just 0, right? So our initial point is going to be the point 1, 0. And now let's plug in the final point for t into these equations here. So if you plug in the final point for t, where t is equal to 1, we're going to plug this in here. So x is equal to 3 times 1 plus 1, as we've done it before, which is equal to 4. And y is going to be equal to 4 times t, and t is 1, right? So 4 times 1, which is equal to 4. So this is the starting point, and the end point is the point 4, 4. So if we find the distance between this, remember that the distance is just going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. So the distance is going to be, let's call this x1, y1, and x2, y2. So we're going to have, oops, I forgot a square here. So we're going to have x1, so 4 minus x2, 1 squared, plus y1, which is 4. 4 minus y2, which is 0, so just 4 squared. And the distance is therefore going to be the square root of 4 minus 1 is 3. 3 squared is 9, plus 4 squared is 16, which means that the distance is going to be the square root of 9 plus 16 is 25, and thus the distance is going to be 5. So we can see here that, yes, they match up, whether we do it through calculus by eliminating the parameter t, finding a function of x, and then using the arc length formula, or we just do it using the distance formula by measuring the distance of the endpoints. We get the same answer. And so that's it for problem number 10.